Hello dear students, welcome to a new math class. Today we'll be talking about representing the linear relation graphically. If you check example 1, the question says represent the relation x plus y equals 5 graphically. X plus y equals 5, so we want two values. When we add them together, the result is 5. You can say 1 plus 4 is 5, 0 plus 5 is 5, 2 plus 3 is 5, any two values you want. And we can represent this on a table. Let's check this. Find three ordered pairs satisfies the relation. As we said, it can be 1 and 4, 2 and 3, 3 and 2. And we can also put this ordered pairs in a table. So if you put x equals 1, then y is 4. If you put x equals 2, then y is 3. If you put x equals 3, then y is 2. We can represent this on a graph. Here's the xy coordinate plane. We plot the first point 1 and 4, the second point 2, 3, the third point 3, 2, and we connect between them. So as we can see, the graph is a line. So the linear relation, when we put it on a graph, it forms a line. Example number 2. Represent the relation x plus 2y equals 6 graphically. To represent this relation graphically, we need to make it as x equals or y equals. So we can write the equation as x equals, move the 2y in the other side, so it will be x equals 6 minus 2y. After that, we're going to use the substitution table to put values of y and find its corresponding values of x. So if we put y equals 1 like this one and we replace it in the equation, so x equals 6 minus 2 times 1, which is 4. Then this means when we put y equals 1, the x is 4, and that forms the ordered pair 4 and 1. We can do this with the 2 and with the 3. So we'll get another two ordered pairs, 2 and 2, and 3, 0. We're going to plot these 3 points on the xy coordinate plane, and we connect between them. They're going to form a line. This is how we represent this relation on a graph. Let's now move to some special cases of the relations. Example 3. Represent the relation x equals 3 graphically. As you can see here, there is no y. X is equal to 3. This means what? This means that x has a value of 3 regardless or for all values of y. So if y is 0, x is 3. If y is 1, x is 3. If y is 2, x is 3. So x has a value of 3 with all values of y. So if we get ordered pairs, they can be 3 and 0, 3 and 1, 3 and 2, 3 and 3, and so on. Then you can represent these ordered pairs or these points. You can plot them on the graph. You connect between them. They're going to form what? Yes, excellent. They're going to form a vertical line. X has a constant value which is 3 for all values of y. The substitution table will be x has the same value which is always 3, and the y value can be changed. So we get the graph. We plot the 3 points, 3, 1, 3, 2, and 3, 3. We connect between them. They're going to form a vertical line. So the relation is represented graphically by straight line parallel to the y-axis and cut the x-axis at the point 3, 0. Example 4. Represent the relation y equals negative 2 graphically. This relation is similar to the previous relation. The difference between them, the previous one was x equals a constant, and this one is y equals a constant. In this example, it's so similar to the previous example. In the previous example, we had it as x equals a constant, but in this example, it's y equals a constant. Similarly, as we did in the previous example, this means that y has a fixed value for all values of x. So, if x equals 0, y equals negative 2. If x equals 1, y still equals negative 2. If x equals 3, y still is equal to negative 2. And when you plot the 3 points on a graph, they're going to form a horizontal line. Right? This is exactly as we did in the previous example. So if it's x equals a number, it forms a vertical line. If it's y equals a number, it forms a horizontal line. Let's go and check how are we going to represent this case on the graph. Y has constant value, which is negative 2 for all values of x. The substitution table will be if x equals 1, y is negative 2. If x equals 2, y is negative 2. If x equals 3, then also y is negative 2. If you get the graph, plot the 3 points, 1, negative 2, 2, negative 2, 3, negative 2. Then when we connect them, they form a horizontal line. The relation is represented graphically by a straight line parallel to the x-axis and cuts the y-axis at point 3, 0. Let's note that the relation ax plus by equals 0 is represented graphically by a straight line that passes by the origin point 0 and 0. Let's see this example, which is example 5. Graph the straight line which represents the relation 2x plus 5y equals 10, and if this straight line intersects x-axis at the point A and y-axis at the point B, find the area of triangle OAB where O is the origin point. As you can see here, the relation 2x plus 5y equals 10 can be represented graphically by a straight line that cut the x-axis at point 5 and 0. When we say it cuts the x-axis, so automatically the y value is equal to 0. And when we say it cuts the y-axis, this means that the x value is equal to 0. As we can see now on the screen, that it cuts the x-axis at point 5, 0. And it cuts the y-axis at point 0, 2. If we connect between them, they form a triangle. To find the area of this triangle, it's half times base times height, where the base is OB and the height is OA. So the area of this triangle is half times 5 times 2, which is 5 centimeters squared. Let's now move to the evaluation part. And as I always remind you, when it comes to the evaluation, please pause the video, try to answer the questions yourself, then play the video again to check your answers. Question 1. The relation 3x plus 8y equals 24 is represented by a straight line intersecting the y-axis at which point? When we say intersecting the y-axis, this means that we're going to put x equals 0. So we put x equals 0 and we find the value of y. Very simple, very easy. Intersecting the y-axis, we find y. Intersecting the x-axis, we find x. And the other axis, we put it equals 0. So here, we're finding that it's intersecting the y-axis. We put x is 0 and we find y. So it's 8y equals 24, then y equals 3. So it's cutting the y-axis at point 0, 3. So the right answer in question 1 is choice C. Question 2. The relation 2x plus 7y equals 14 is represented by a straight line intersecting the x-axis at the point Which point? When we say that it's intersecting the x-axis, so we put y equals 0. So it's 2x plus 7 times 0 equals 14. So 2x equals 14. Then x is equal to 7, where y is equal to 0. Then the right answer here is choice C. Question 3. The image of the point 5 and 3 by reflection in the straight line x equal 1 is what? When we say that reflection in a straight line x equals 1, this is the straight line x equals 1. It's a vertical line. So to find the image of reflection, you plot the original point and you see its reflection on the other side of the vertical line. So how do we do it? Reflection across this line, we're going to see it now on the screen. So if this is our graph, here's 1 on the x-axis. This is the line x equals 1. If we have this point as 5, 3, so how many units did you move here from the 5 to the 1? You moved 4 units, right? So you're going to move 4 units on the other side. From the 1, you're going to reach the -3. So the image point will be -3 and 3. So for question 3, the right answer is choice C. Question 4. The image of point 4, -2 by reflection in the straight line y equals 1. As we did in question 3, we're going to do in question 4. But the difference here is, in question 4, we'll do it exactly as we did in question 3. But the difference here is that the reflection line is y equals 1, which is a horizontal line. So your mirror is this horizontal line. So as you can see in question 4, our final answer is choice D. By answering question 4, we came to the end of our session today. Thank you very much, dear students, and wishing you best of luck.